So today we'll be talking about the lab 7. To do the lab on the textbook, very simple thing is you need to know how to apply input to the circuitry. That's the first thing. Second thing, how to measure the output. And the last one is if the test it fails, what caused the problem? That's what you need to understand. The process for the lab will be the same almost for every test. Okay, so now we will be talking about the lab 7. That means they will be testing for the IC191 binary counter. Binary counter, that means the counter will be counting. If you get a 4 output, they will be counting 0 to 15 and to 0. That's counting up. This counter also counting down. They can counting from 15 back to 0 and go back to 15. If we already done for the lab number 6, this is a very similar to the lab number 6, except a little thing different. Okay, so now the first thing we need to look into that IC 74191 first. See how many functions we can get. First thing, you don't have any function to clear. This IC, they don't have a clear. But they get the load function. Okay, how do we load it?
It's fine. We don't see your screen.
Oh, you don't see?
For the circuit. Yeah, about the circuit.
Yeah, I left that. Okay, sorry. So now you see it, right?
Yeah.
Sorry. Okay, so this is the lab number 7. Testing IC 191 binary counter. So if you're looking on this counter here, you can see they get 4 output, Q0, Q1, Q2, Q3. That will be telling you they can be counting from 0 to 15. Okay? And also they get the counting up or counting down. You can see on pin number 5. How do we counting up on this input here? If you want count up, what's supposed to be at pin number 5?
Low.
Low, correct. 0 for count up and 1 for counting down. Okay, that's the counting. The next function will be loading, 11. Low, they will be loading. Okay? So when you try to loading, that means Q0 equal P0. Q1 equal P1. Q2 equal P2 and Q3 equal P3. okay, that you get loaded, get a higher priority. That means if you loading, you cannot count it. Okay, then now
Question on loading.
which
40,
pin,
that means the clock, positive clock.
which
0
pin
to
is the
1.
loading, Mr. Pham?
Yeah,
Which pin is the load?
what pin is the load? Pin 11.
Pin 11, okay, PL. Okay, thank you.
PL means parallel load.
One other question.
No, okay, go ahead.
On PA5, that's U1 is not a NOT gate, correct?
No, I was talking about U1.
I know, because I was going to say pin 5 to get a load is pin 5 1 or is it 0, and then it goes to a 0.
Okay, pin number 5, right?
Yeah, U1 pin 5, and then it goes to
No,
U.
I don't care they load you right now. I really care if you want to count up what pin 5 is supposed to be.
No, I was talking about the load.
Load pin 11.
Yeah, but pin 11 connects to pin 6 U1.
Connect your pins U6.
No, pin 6 U1.
Yeah, that's okay. I'm not talking about that yet. I just asking you to loading pin 11 have to be 0.
Right, yeah, I know that, I got that. Okay, go ahead.
And pin 11 is 0. That means Q0 equal P0. Q1 equal P1. Q2 equal P2 and Q3 equal P3. Okay? And when you want to count it, pin 14, you need the clock. They're supposed to be 0 to 1. Okay, schematic. Manufacturer, they get it wrong. They get a bubble. Okay? They're supposed to be 0 to 1. So every time you apply one clock, counter will be counting one number. Okay? Now, E1. E1 just a buffer. Input pin 2 and pin 3. If pin 2 0, pin 3 0. If pin 2 1, pin 3 1, nothing else. However, pin number 1 enable, they must be route. Okay? They must be route. If they're not routing, 2 and 3 cannot be the same. That same U1A or U1B. Just a buffer, okay? And now we go into this IC here, 244. (244) also a buffer. Okay, that means input output will be the same. And they will be controlled by pin 1 and pin 19. If pin 1 0, then the output 18 here and the input pin number 2, they will be the same. Okay, pin number 2 0, output 18 0. Pin number 2 1, output 18 1. Nothing else. And also pin 19, that will be controlled on another for loop for pin 11, 13, 15, and 17. Okay? If pin 19 0, pin 9 will be equal 11. 7 equal 13, 5 equal 15, and 3 equal 17. In this case, they routed both. That means all the time, pin 18 will be equal pin 2. 16 equal 4, 14 equal 6, 12 equal number 8. Also, pin 9 will be equal 11. Okay, and so on. That is U5. Input, output will be the same. In this case, the thing is, they routed both 1 and 19.
Question, Mr. Pham.
Yeah,
What is the job, the purpose of the buffers on the circuit?
I given you example. If pin
Wonderful.
2, logic 1, you can get 2.5 volt. That's logic 1. However, when they go to the buffer pin number 18, they want to bring it up to 4.55 volt. That means to standard logic. They try to increase more current. Okay? That is the reason why they're using the buffer. Input, output the same, but the voltage can be much better when they go into the output of the buffer. Input pin number 2, logic 0, you can get 0.4 volt, logic 0. However, when they're coming out, they can be go into 0.1 volt. Okay? I mean, make a standard.
And that also apply for U1 and UB?
Exactly. Same thing.
Okay, thank you.
One they get a 8-bit, one they get only 1 bit at a time, depending on the application. In this case, I need only 2 input for pin the clock and pin parallel load need the buffer. So I need to using 74.121.25. And the other one I get 8-bit, so that's why I need to using 74.244. Just the buffer. Okay? Input, output the same. Okay? And CE, count, enable. They routed. That means on the time they are allowed to count it. Now, if you're looking at the U4, also they get the Q output, RC, and the TC. So now you're looking into the data. Data 74.191. And the timing here. Try to learn how to read the timing. Okay, now, first thing you can see is load. When they load, they want to load. And you're going down, okay? What A, B, C, D equal? A1, B0, C1, D1. What number? 1, 1, 0, 1.
The hex data is B.
What that number?
The number 11.
No.
No.
No,
13.
1101 number 13.
that's
13.
D, that's D.
D. Number 13. Okay. There.
0x0D.
Okay. So when you loading, you see that QA will be 1, 0, 1, 1. That means whatever on ABCD, they will be coming out the output of the counter. If I load 50101, then they coming out 5. I load A 1010, they coming out A. Okay. Now, if you're looking in here, they say load 13. Then now they counting up. Okay. So 13, you counting, you apply the clock, they will be go to 15. Okay. And after they go to 15, they will be go to 0. And they stack 1, 2, 3. Okay. So basically, the counter will be count 0 to 15, then 0. Keep going. Okay. In here, they cannot draw everywhere. Everything from 14 to 15 to 0, 1, 2, 3, 4, 5, 6, up to same thing. They just telling you, okay, now you get the output will be, okay, RCO, and also max and the minimum, okay? So see what happened on that output. Okay, max and the minimum. Let's see, what and the minimum. Let's see, what pin for max and the minimum?
12.
12, okay? And output ripple clock 13. Okay, now output 12, active high or active low?
Active high.
Very good. You can see no bubble. Active high. Active high means normally what logic?
1.
1.
1. Okay, so let's see on the timing diagram here. Okay, active high, that means when something happen, they go high. Okay, they going high. However, normally they will be low. That means active high. And the other one, RCO, they get a bar over, active low. That will be telling you what happened. Normally they high, and they will be going low. Then they go back high again. Okay, so if we're looking into here, we can recognize few things. Okay, when the counter rate 1, 1, 1, 1, you see that? So the max and the minimum go up. Okay, and the RCO going low. Okay, so RCO, that's for counting down. Max minimum for counting up. Okay, however, on the schematic here, RC pin 13 active low, that means they high on the top. DC12 active high, they will be low on the top. Okay, then they go to just the buffer. Okay, and this also the buffer, and they go to the AND gate. So they're telling you when they counting up to 15, and they get a pulse coming out here. Okay, and they get a pulse coming out here, they connect to the clock of U3. And U3, D flip-flop, when they connect not Q back to D, they working like toggle. So if it's 1, when you apply the clock, they go to 0. If it was 0, you get a clock, they go back to 1. That is divide by 2. Toggle on the time. So this is what they try to do. That means when you're counting up, then pin 5 have to be 0. That means pin 5 here have to be 0. If they counting down, pin 5 must be 1. Okay? So at the beginning, if you load it, what pin 11 supposed to be?
Low.
You want to load.
0. It's an active
0.
low.
Okay? That means you have to apply PA05 PL here is 0. Now, if 0 go into here, and they go down to U3, go to set this flip-flop. So pin number 5 supposed to be
1.
1. If pin number 5 to be 1, then that means you start counting down. You see that? You must be counting down.
Yeah, and if it is 0, it's counting up, right?
0 count up.
Okay.
But at the beginning, when you load any number, then pin number 5 U3 must be 1. And that means you start counting down. Okay. When you're counting down, that means 15 down to 0. Then you get the pause coming out here to U2 and try to apply the clock to U3 pin 3. Then output will be toggle. That means pin 5 now will be 0. And 0, that will be telling you now you start counting up. Okay? So they counting down first and they counting up later automatically. Okay? So for this circuitry, first thing you will be apply loading number. Okay, if you're looking into requirement here, see that number 1, they will be load 1010. Number 2, they require load 40101. Number 3, load 000. And number 4 will be load 1111. And now also pin test number 5, they say I want test U5. U3 pin 5 at logic 1. That means U3 pin 5 at logic 1 for counting down. Okay, test counting down. You see that? Then after that counting down, you test counting up. And after you count up, we want to go back, make sure they will be toggle again and get one more test to make sure they count down. Okay? So if you're looking at the output here, pin number 5. Pin number 5 control up or down of the counter. 1, they counting down. 0, they counting up. After the counting up, automatically they have to go back to counting down. So that's why after they counting up, make sure you get a pause coming out here, clock into U3 so they toggle again. Only thing is what you need to do, if you're looking on the test here, first thing I'm talking about load number 8. Then how do we apply input to this circuitry. Okay? And how do we verify the output? So basically you apply the load in here, 0 here, you apply pin number A1, A2, A3, A4 for P0, P1, P2, P3 look like number A. Okay, that means 1, 0, 1, 0. So when you load, they go here, and you go to read input C. Now, if it fail, what peak of you think for the load number A?
U1, U4, U5?
Perfect. U1 or U4 or U5. If you're confusing or do not quite understand, just let me know. That is the load number A. The load number 5. That means you apply number 5 in the input here, they go this way. Go back to the P0, P1, P2, P3. And now you can read it out. Will be number 5. This test, if they fail, what caused the problem?
It's the same. U1, U4, U5.
Okay, U1, U4, U5.
All the loads are like that.
Same thing, right?
Yes.
The test number 3, they load 0. That means they apply 0 here. They go in back in here, 0, apply load 0, you get 0 right here. And you're supposed to get a 0. Now, what is the pickup?
It's the same.
Now,
What you mean for the clear or pre?
now not clear. I say I load 0. You get for test for the loading. Load A, load 5, load 0, load F. We already done for load 5, load A. Now I want to loading 0. That means you have to apply 0 here. Okay, they go to P0, 1, 2, 3 is 0. And the 0 right here, they go 0 here. And you reach 0. My question is, if that fail, what pickup? What caused the problem?
U3.
We do nothing with U3. Right now, you're still on the loading test.
Oh, okay.
Should be the same U1, U4, U5, isn't it?
Not mean the same.
Is it, would you check PA5?
PA number 5. No, not yet. Right now, still loading. You can looking into the handout here. You see that? Number 2 loading 5. Number 1 loading A. Number 3 you test loading 0.
Well, I would check U1 because we've already proven that U4 and U5 can see zeros where it needs to.
Now,
So Mr. Pham, can you say that again? So I think I missed something here. So you're loading 0, all zeros this time, correct?
right.
So what is your question again? It's why is it,
On that test number 3, what the P-COP supposed to be? What caused the problem?
well, first of all, if it's not something wrong, you got to check to see if pin 11 on U4 is active low.
Now, I just talking about P-COP. I'm not talking about isolation. What do you think? How many IC involved on that test?
Just U4,
Yeah, you're right.
U4.
because the other one, we already tested it.
Now, I can tell you one thing. How come in the digital they test for
He just being
1, 0, 1, 0. And also they test for opposite 0, 1, 0, 1. The thing in the digital, they get only two things. Either they 1 or they can be 0. So normally for the digital circuitry, any input output will be testing for 1 and 0. Okay,
Yeah, that's why you use 5 and A all the time.
right. That is the way for digital testing. If they already passed it, okay, that means they can be okay.
It
Like
gives each output pin a chance to be tested for high and low.
right, input or output the same.
Right.
Okay, when you testing for 1, 0, 1, 0, or 0, 1, 0, 1, you already testing for U1. U1 must be working. So that's why you can get a correct for test number 1 and test number 2. And this U5 here, we already test pin 2 for 1, then 0, pin 4, 1 or 0. This one also. That means nothing can be wrong in here. Okay, they already testing for 1 and 0. And when you apply here, same thing. You only apply 0, then 1. That means nothing can wrong with this guy anymore. Nothing can wrong with this guy anymore at that number 3. Only one thing is this U4, they not doing things right inside here. So the peak off for this, that number 3 is supposed to be only U4.
But that could occur even if tests 1 and 2 pass.
Yeah, 1 and
Test-
2 must be passed before you can test number 3.
Okay.
You understand it, that thing. You will get that 1, 2, 3, 4, 5, 6, so on. If you fail on 1, you have to stop on 1, fix that first. Cannot test number 2. Or if you fail number 2, you have to stop to fix that first before you can test number 3.
But if we have tested U4 in the same way that we've tested U5, and all of the pins have been tested for high and
No.
low, and we're not changing any other parameters of how we're using U4, then how is it U4?
U4, that means inside they not loading the same thing for that combination.
Okay, it can just be a
That-
fault
that-
just for that combination.
Yeah, that's just the counter inside.
Okay.
They can be loading 5, okay, but they're not loading 0. Who knows? However, if 1 cannot be failed, if they fail, they will be fail on test number 1. Cannot up to test number 3. And also U5, same thing. If they fail, they must be fail at test 1 or test 2. The thing is on input output already test for either 1 or 0.
Okay, thank you.
Yeah, the test number 3 fail. Peak off will be U4. And the test number 4, now they testing 1, 1, 1, 1. Same thing. If it fail, they must be U4. So if you're looking into here, okay, let's see, you loading, okay, first one will be U1, U4, U5. Okay. And the next one here, okay, load 0, load 1. So this may be map data will be the same, but the peacock must be changed. Okay, the peacock now have to be U4 for correct. Okay, and this one also have to be U4. So you need only one U4, we don't change it, then I change it back here. Okay, so this have to be U4,
That's for test 3 and 4.
3 and 4. On 4, we're not changing, so that's why we not allow you to writing into that. Okay, you will be right to this one.
Yeah, but on those, Mr. Pham, you grayed out that whole area.
Yeah, now I change it.
Did you change it on the web?
Will be. Okay. Okay, so that will be test U1, test 1, test 2, 1, 2, 3, 4. Any question on that? And now, number 5 will be test U3 pin 5 for logical 1. Okay. What peacock?
U2, U3?
U3 only.
Yeah, it's either that or U3 only.
U3 only.
Ah,
The
good
thing
job.
is you apply 0 here. They go into preset. Then U3 pin 5 must be 1. And this guy already test in the test 1, 2, 3, 4. So nothing wrong. So that one and U3 only. Let's say that preset here. Okay. U1, U3, that are wrong. Will be U3 only. I will be update for your guy. Okay. U3 only. That make sure I know which one I will be correct. Okay. Okay, now we start counting down. So this line already pin 5, U4 pin 5 already 1. And you start counting down. Now, if they counting down, it fail. They will be count 15 to 14 and so on. What caused the problem?
Up and down, so it's U4.
That means output will be from 15 go to 0. Now, it did fail. What caused the problem?
Should be U4, isn't it?
You're perfect. They will be U4. Nothing to do with U5, right? But the thing is, U4, but still get missing one. Can you tell me? On that counting down. Who knows? Pick up will be.
One.
Now, nothing to do with U5 anymore, right? U5
U4.
already test for combination 1, 0.
The good money is staying with U4.
I say still missing.
Unless it didn't get the right logic out of U3.
No, U3 you already verify on that verify preset. You already make sure they get a 1 already.
One.
Wrong with U3 pin number 5.
Okay, 50-50. I'm staying with number 4.
Okay, I tell you. You forget this guy.
One. Okay. U1 clock.
Yeah, the clock, if this guy not working, the clock not coming.
Oh, yeah.
You see that?
Mhm. U1A.
U1A.
Because you need a clock for every count, right?
Right. However,
You don't use it when you're loading though.
no, that's a different. Even they same U1, but U1A different U1B, U1C,
Right.
U1D.
Right.
Okay, I testing already U1B, but not U1A. So now, if the counting down, it failed, they can be either U4 or U1A. You get that?
Yes.
However, when you do the test, you understand. If you get a 15, they counting down to 14. If they fail, then U4 and U1A. However, if they count from 14 to 13, they fail. They cannot be include this guy. First counting, they include both. However, for second counting, it failed only U4, not U1A. If U1A is something wrong, they must fail the first counting, not the second or third or so on. So that's why normally you have to using the if statement inside the loop, okay, to isolate the peacock. And now we see port ABC here, okay? So counting down, okay, from 15 to 14, if they fail, you say U1 and U4. However, the rest of the counting, you want U4 only. Can you follow that? That means you must be using the if statement inside the test program. Maybe I'm not loading that program. I do. Okay, let's see. You see on the counting down for integer j, okay, equal 14, j greater than equal 0, j minus minus. So the first line will be increment cat number. Now, they say it right here. If y equal 14, that means the first counting. You want pick up to be 1 and 4. L, that means after that, I want pick up only number 4. Okay? This is software. Okay, that will be counting down. After you counting down, now you will be testing counting up. Okay, number 7, counting up. So basically what happened here, after they counting down to 0, you get the pulse coming out on those 2 guys here. Okay, and together, then you get the positive pulse coming here and apply your clock up U3, they toggle. So this now will be 0. And they apply the clock, they will start counting up. So in here, is it they testing for, let's see. Okay, they not testing for this guy. After they counting down, this line is supposed to be 0. I want to see on the port ABC here. Okay, they count down. You see that? Down, down, down. Okay, they count down to 0. This output here, preset. Now also you have to verify that to be 0. That means after you testing for countdown to 0, this also you verify this guy have to be 0. That means you get a clock here and this toggle. Okay, so on the last one here, okay, you can say now you want to test this must be 0 on output of the counter to be 0. So the math data will be 0x 1f. And if that fails, okay, let's see, U1, U2, U3, U4, how come? When you test the last one, that means including U3 pin 5. If they fail, okay, they say U1, U2, this guy here, U1C, U1D. Okay, the thing is, if you get a pulse coming out here, if they're not working, they cannot go in here. And also, if they already coming here, if U2 not working, they're not coming out here. So that's why U1, U2, then they apply the clock here. Okay, they have to be go back to 0. Okay, so that means U3 and also go into U4. They're not working. That's why on this test, the last one of the countdown, if they fail, they can be U1, U2, U3, and also U4. That's what in here. U1, U2, U3, U4. Then they will be start counting up. Anything wrong will be U4. Okay? And the last one, counting down to 14, you want that to be a 1 again. So if they not 1, they can be U4 or they can be also U3. So now, in order to do, first thing what you need to do is you go into here, port A, B, C. First thing you said, number one, load you apply will be 0x, 0A. That means you're testing for load A. Okay. Then you go into the output here. You verify A. So output supposed to be 0x, 0A. And also math data will be 0x, 0F. And this is the peacock. That's only thing which we want you able to understand for test number one. And for test number two, you're loading 5. Then you have to write to port A 0x05. And you go into port C, you read it, and they will be 05. Okay, math data the same. Okay, L1, L4, L5 the same. You don't have to type it in. What happened after you complete that part, and after that you don't care about the circuitry. Now we're looking into port A and port C and transfer that into the coding. Okay, now any question? Anything? Mr. Smith want to ask me what?
When are you going to do the update on the web? Because you got to change the peak off.
Yeah, I can maybe change the peacock.
Yeah, but I'm saying, when are you going to do it?
That I'm doing after meeting.
Okay, so maybe in like an hour or two after the class, it'll be updated, correct?
Correct.
All right, thank you.
That's easy.
Mr. Fan, basic question. The RCO mean a ripple clock is.
Yeah, look like. It doesn't matter to me. Only thing you need to understand RCO will be going low. When?
Mr. Pham, on the data sheets
Yeah,
that show the timing, what is the CTEN?
here, right?
Right, under the clock,
Under the clock,
and
right?
then going down is down and up, and then under that is
Up and down. You want
Right.
up or you want down?
right, and then you got
up.
CTEN.
D,
CTEN, the next one.
enable, counting enable.
That's enable.
See,
That's, so that one is equivalent to pin 4 and pin 5 then, right?
that's only telling you pin number 4, 1, you're not counting.
When you are not counting.
Yeah, if it's 1.
Okay.
But on this circuitry I routed, that means they're counting all the time. If you want.
So that's always 0.
The thing is we routed.
It's grounded, so it's always 0, so it's always counting.
Yeah, always you want count, they count up or you want count down. Doesn't matter.
Okay, so that's enable that is.
Yeah,
Okay,
And
thank
now
you.
for counting. Allow counter to counting number. Up or down, doesn't matter.
Thank you.
Yeah, the thing I try to understand that as a real technician, you have to deal with that. Okay. If you want to troubleshooting the circuitry, you must be at least basically understanding. Try to learn how to analyze the test. If they fail, what caused the problem? Anything you get a problem, okay, then you can in Zoom, let me know. I can on Zoom with you. That will be helping you to understand and get the problem done quickly. If you don't know how to do what to do, don't do it. Have to be asking. Remember, from now on, most of the lab will be not run simulation. The thing in the P5, we don't have a library. The park in the library. So that's why nowhere you can run. Only thing we try to let you understand the IC and you can analyze it. That are important to you. The thing at work, some IC you don't know. Go to the Google and you can get the data. That's what I try to teach you, how to reading the data. Okay? Any question on this thing? Okay, you don't know anything to add? Okay, now I try to share with you data from IC. This is 244. We just know the 244. And will be made by Fairchild. Okay? They say buffer, line driver, and line receiver. This is the inside.
Whoa.
You see that?
Yes.
That means pin 1. Okay? And also pin 1 and pin 19 is a control. Pin 2 go to pin number 18. Pin 3 go to pin number 17. Okay? And so on. However, pin 1 will be controlled. You see that? They control pin 2, pin 3, pin 4, pin 5. However, pin 19 here, they will be controlled 1, 2, 3, 4. So basically they separated 4 in, 4 out, controlled by pin 1 or pin 19. Okay? Input output will be the same if pin 1 0 or pin 19 0. That's just a buffer. Okay? Let's see.
Mr. Pham,
Okay, they don't have any data in here. They just the IC. Okay, let's see. I can see another one here. Okay, let's see. $540. Okay, $244 here. $190. Okay, 334. We not deal with that today. Okay, that's what I'm working on. So I try to give them to upload for you guys. Okay.
Hey, Mr. Pham, so the main point of the buffer is you got an input side, the output side. Whatever goes in comes out. But on the output side, hopefully the current is been increased and give you a stronger voltage, correct?
Exactly.
Okay.
Buffer just try to increase the current.
But it will lower it for a logic 0 too, closer to 0?
Yeah,
Is that what you said? Okay.
close to 0 volt. And the logic one, they want to go to 5 volt.
Right. Okay.
Okay, let's see. This one still don't have a two table. 344, 355. No, not yet. Okay. So let's see. Let's see which one is it here. That will be 139, not yet. Okay, 373, not yet. No, not yet. Okay, I will try to working on that and upload for you guys all of the things you need to know about 244 and also 125. The flip-flop you already know. Okay, and get or get doesn't matter.
Hey, Mr. Pham,
Yeah.
I'm just asking the question only, just asking only. Do people sometimes get the because of the triangle looking shape, they get the 125 and the inverter mixed up?
You mean if they get an inverter?
Because the inverter, the symbol for the inverter is a triangle like that, the same as that, only except for you got that ground there. I'm saying, do people get that mixed up?
Okay, no. Now, if you get a data for this IC, and you can understand P number 1, they call enable, active low. That only telling you pin 1 must be 0, so 2 and 3 will be the same. If they not 0, pin input 2 and output 3 not the same. That's what they call enable. I will be get that for you guys also. So normally, if the people know how to do, you can get it done quickly. Okay, on that program here, I already given to you a loop for counting down and a loop for counting up. And when you read it and try to make sure you understand each lines of the coding, they just repeat the same thing. If you want to do the loop for how many times, you have to using the for loop for from what to what, increment or decrement, and open the bracket inside. All the time you have to get increment that number. In this case, you want to apply the clock and you want to get the exact data and measure and that for the loop, any loop later on. When you testing the memory, same thing. The loop can be from 1 to 1,000. That means there's 1,000 tests or 512 tests. You don't want to keep typing 512 tests. That's what you have to say. Okay, 4j equal 0. And if they less than 500 or equal 512, then you increment. That means you want 512 tests. And just few lines of the code. Then you can get through everything. You don't have to type in 512 tests, no way. I know.
If you start on Saturday or Sunday, you can be finished by Monday.
Yeah. If you can finish that Monday, then you're doing a perfect job.
I'm just making fun, Mr. Pham.
I,
500 tests is a lot to
yeah,
take.
I already given to you this thing here. Easy to get it part. Okay. Only thing I have to generate something in here. Okay. Only 2 things need to be changing.
You got to make sure yours get all ones instead of zeros.
What do you mean 0, 1?
No. You didn't hear me. You got to make sure those are all ones.
Okay. So basically, I need to correct something.
You need to correct the peak offs only.
Right. That only thing. So we want that to be 0800. And U4 only. Okay, let's see. How come they not? Okay, 0800 here. And no, we don't need that. U4 only. Okay, and I correct this one. So they will be U1, U3, so that should be U3 only. Okay, so that will be perfect. And I will be upload after the meeting.
Okay.
Okay.
All right.
So any question, anything? You guys think you can do it?
Yeah, Adam can do it with no problem. We'll copy off of him.
Right.
It's too easy.
Hey, Adam, we'll copy off of you.
Uh-oh, we're all in trouble.
That be very, very good. Okay. To understand the thing is before we in the class, I'm not going into much detail. Okay.
This is better you go into detail, Mr. Pham.
Exactly. That's what I want you to understand. The lab is not hard to do. You just build it. Okay. And now you run the test using your test program. So if it fails, then you have to know what's going on, what to do. I given you example. If you run the test number A and they fail, now we're talking about troubleshooting. What can we do? If you run test number 1, okay, that means you get 1, 0 here, 1, 0, 1. But they fail. If you know how to do, tell me, what can you do?
You testing pins 5 and 6 of U1B to see if they're low.
Okay, now, hold on. I just want to write down here. Let's see. You want 1. Okay, so that
You said, Mr. Pham, you said on the output, you wanted to get 0x0A on the output, but you did not get it.
now, okay. I can tell you next time I will be using iPad to teach you troubleshooting. Now you suppose to get the output will be 1 here, right?
Right,
0,
right,
1,
right,
0.
right.
Okay. When they fail, first thing, what you tell me what to do?
You go backwards. You go to pin 8,
No,
6.
not yet. Just tell me what you need to do. You not go backward or whatever. I don't care right now. But now they can read 0, 1, 1, 0, 1, 0. When they fail, okay, I telling you.
You want to check load.
No, not yet. That's what I said. I telling you what to do.
Okay, go ahead.
First thing, when you fail, they bring it out. Expect data. 1, 0, 1, 0. Right?
Right.
Now, measure data. Then you see which output failed,
Which pins?
which pin. That means they say they read pin number 12 will be 0. Instead, they will be a 1. Right?
It's supposed to be a 1, but you say it's a 0.
Yeah, that's what they measure.
Right.
So you know it failed on pin 12.
Right.
Now, what you need to do, going back
To pin 8.
number 8. Okay? And when you measure using meter, measure pin number 8, either you get 0 or you get 1.
Right.
Now, first thing I say, if you get 1 here, what can you do?
Well, in this class, you check the wire, but you said in industry, you can't do that.
Yeah, but that's what I'm talking. When you take the program telling you they read 0 here, but you want to be a 1. You now fail right here. You going back pin number 8. You take the measure. 2 things you can get. First thing I say, you get pin number 8, you get 1. Tell me what next you want to do.
Make sure your output is not grounded.
No,
Replace U5?
no, not yet.
Test pin 1.
Exactly.
Oh, yeah. You got to check 1 and
You have to make sure pin 1 must be,
1 and 19 is grounded.
I see.
okay, must be routed. You get that?
Right.
Now, if you see it round, okay, then you can replay U5. The thing is you get the right input, but you not get right output.
Hey, Mr. Pham, I know what you just said right there, but also too, would you have to make sure that pin 12 isn't accidentally touching ground?
No, we're talking about at work. They cannot connect to the route.
Maybe it's a mistake, an accident.
Only thing, something wrong with the pin 12, if you already can U5 and they still the same. That means something wrong with that output. Some go somewhere. But that is normally the way troubleshooting. You get a wrong output. If you get a right input, then that I see.
Right.
So that's why you can see that by looking at the output, you know which one caused the problem, what pin number. Okay, now, if you measure pin number 8 here, also you get 0. That means 0 here, you get 0 here. This guy look like okay. What next?
Checking pin 7 of U4?
Exactly.
Yeah.
Then you want to check, make sure U4 pin 7 supposed to be 1. Okay? If you get a 1 here, the wiring get a problem. However, what I'm saying in the company, we don't deal with the wiring. So pin 7 supposed to be 0, the same what you get here. Okay, that means you get wrong on pin 7. What next?
You got wrong on pin 7. Let me see.
Are you saying pin 7 you got a 1?
You want it to be a 1, but they not.
You check pin 9.
But perfect. You take pin 9. pin 9 supposed to be go to pin 7.
Right.
Now, if you take a pin 9, okay, you supposed to get a 1, but you not get a 1. What night?
In 3 of U5?
3, yeah.
Okay, then you see where they go, right?
Yeah, you keep working backwards.
Okay, so U3 of pin number 5 supposed to be 0 also. The thing is we not deal with the wiring, right?
Mhm,
If you're working in the lab, you have to pay attention on the wire,
mhm.
okay? So now they can be wrong on pin number 3 here. Then what next?
Then you gotta go to U517, and that goes to PA4, which
17,
comes,
you will be get a 1.
you get a 1 there?
You must be get a 1. The thing is that from the system cannot be wrong.
Right, that comes from the control box.
So this is the 1 here and you get a 0 here. Then you have to make sure pin
Round
1,
19.
19 must
Oh, 1
be
and 19.
rounded. If you get 19 rounded, you get a 1 here, you get a 0 here, then U5.
U5.
That is how to troubleshoot it. When you see, when you build the circuitry, you run the fail test number 5. Then test number 1, load A. Then you're able to fix very easy. If you really know how to do what to do. Why, in the past, the people fail and they ask me to help. I just tell them to measure. And I telling you, wiring wrong or the IC not working. Okay. If you know how to do what to do, you don't have enough time to do your job. The thing is, only thing you don't know what to do. So that's why it take time forever.
Mhm.
At work, the same thing. When you run the test for the circuit board, if they fail and you know right away which way you go to do, then I believe you have not enough time to try to fix the problem. That's really, really happy for the people at working. You don't pay much about the time, 8 hours, not enough for you to do your job. If you don't know how to do it, that means that's why you're waiting the time to go home. Okay, so I will be upload this file for your correct. Next week we will go into test number 6 and test number 7, helping you to learn how to make a troubleshooting when the test fail. Okay, and when you get a chance to build, I believe we can get very soon happening. I will allow you to borrow the test box on off the IC and the wiring you can build at home. We have to do that way. Otherwise, really not good for me. Then at your home, you can build, you can test, and then they fail. Okay. Then we'll be helping you how to fix that. Every time I will be allowed 10 people to borrow. We support everything and on of the IC, on of the wiring. You guys to build. And then that time we will stand only for everyone verify the test. And if it fail, then now we can work together, try to fix the problem. Okay. All not 10 students must be get through that. So that's why when the office go back to normal, we can give your guy the certificate, no problem. The thing is now we want it, we cannot do it. Nobody in the office, nobody doing anything.
Only you, Mr. Pham.
Yeah, that give me too much. You can see from either take one or take two, this time I quite teaching different, right?
Right.
The thing I feel that are very good to helping you to understand. The lab, you have to know how to using meter, oscilloscope, no problem. A generator, then you'll be okay. The circuitry, too many circuitry, how can we learn everything? No way. Learn the way to do the job. Okay, any more questions?
Good night.
I say, if you don't know, try to get in touch with me to helping you. You don't want to stay forever with me.
I do. All right, good night, Mr. Pham.
Okay, so good night, everyone.
Mr. Pham,
Thank you.
Yeah.
do you record?
Yeah.
Do you recording? Do you recording?
Yeah, I got it.
Yeah, thank you very much.
Okay, we brought it out. Right.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.